This is day 12 of Unit 4. We started today with this warm-up, so take a moment, pause the video, try the warm-up, then play to check your answers. So we have factoring. So first try for GCF. Looks like there is a GCF. So that's a 2. We're left with x to the 4th minus 81y to the 4th. And hopefully you didn't stop there. That factors further. So that's difference of squares, x squared plus 9y squared, and x squared minus 9y squared, which I'll just bring it over here. So the x squared plus 9y squared does not factor. Hopefully you didn't try to factor that. But the x squared minus 9y squared does. That factors into x plus 3y and x minus 3y. And that is your final answer. Sorry, I got kind of messy there, but that is the final answer. Next one, grouping. So GCF x cubed, x squared minus 1, copy the x squared minus 1, and that's going to be times an 8. So then one term's here, one term's here. The GCF, which we pull out front, is an x squared minus 1. I only write that once because it's a GCF. It's a common factor. I'm left with x cubed plus 8 when I factor out that x squared minus 1 GCF. Now, hopefully you didn't stop there. Both of these factor further. We have difference of squares and sum of cubes. So we have x plus 1 and x minus 1 for difference of squares. And we have sum of cubes, x plus 2, x squared minus 2x plus 4. And that is my final answer. So today, in our notes, we looked at graphing quadratics. Every example from today is actually in your worksheet booklet. So you need to find worksheet number 2 in Unit 4. And this is problem number 1. You will need to graph these. You're going to do some graphs today, so you'll need to put a coordinate plane into your notebook. But we can put the work there in on your worksheet. So it asks for the x-intercepts, the y-intercept, the vertex, and the graph. So let's start with the x-intercepts. So we remember from previous units that the x-intercept is when y equals 0. So I'm going to substitute 0 in for y, and then I'm going to solve for x. So I see that once I've done that, this is in vertex form, which means I can very easily solve for x by using the square roots technique. So I'm going to bring -1 over. And then I'm going to divide by -4. So -1 divided by -4 is positive 1/4. Now I have it in the format that I can take the square root of each side. On the right, the square root of x minus 1, the quantity squared, is the absolute value of x minus 1. And on the left, the square root of 1/4 is 1/2. So we have x minus 1 is equal to plus or minus 1/2. And then adding 1, x equals 1 plus or minus 1/2, which we can simplify further. 1 plus 1/2 gives me 1.5. And 1 minus 1/2 gives me 1/2. So we're getting, writing those as coordinate points, 1.5 or 1.5, 0, and 0.5 or 1/2, 0. So I'm going to go ahead and, if you didn't already make a coordinate plane, go ahead and do that and plot the x-intercepts, 1.5, 0, and 1/2, 0. Okay, next we're going to find the y-intercept. So y-intercept, remember, is when x is equal to 0. So let me go ahead and put 0 in for x. So when I subtract 0 minus 1, I get negative 1. Squared is positive 1, so I have negative 4 times positive 1, which is just negative 4, plus 1. So negative 4 plus 1 is negative 3. The y-intercept is 0, negative 3. So I'm going to plot that right there. So I have the y-intercept and I have the x-intercepts. I need the vertex yet. Vertex, so I'm going to look back to the original equation, and lucky for us, that one's in vertex form. So we know from earlier in the unit that minus 1 is right 1, which means the vertex is at 1, and plus 1 means up 1, so 1 for y. So 1, 1 is my vertex. So I'm going to go ahead and plot that 1, 1 right there. And that makes sense because that is halfway in between the x-intercepts. Now, you learned in probably Algebra 1 that with a parabola, parabolas are symmetrical, and there is what we call a line of symmetry that goes right through. It's a vertical line that goes through the vertex. So if this is my vertex and I'm thinking about this vertical line, now it's not really part of the graph, but it's kind of an imaginary vertical line. If I were to draw that in, then remember that points are like mirror images of each other. So if I think about that vertical line being drawn through the vertex, then this y-intercept has a mirror image, and the y-intercept is 1 away from where the vertex is, which means if I go 1 in the opposite direction from the vertex, I can plot a point there because it'll be the mirror image of the y-intercept, which is already there. So now we have perfectly symmetrical parabola, and we can go ahead and graph it from there. On your graph, you should label the vertex 1, 1 and the intercepts 1.50 and 0.50 and the y-intercept 0, negative 3. And that's the graph. Okay. Next, we're going to move on to number 2 on the same worksheet. And again, you'll need a coordinate plane for that. So the first thing we'll look at would be the x-intercepts. So remember putting 0 in for y, or f of x in this case. Solving for x. So I see that this equation's in factored form, not in vertex form like the last one was, and not in standard form either. So when I'm trying to solve for x, think about this. I have a factored equation set equal to 0. So don't make this harder than it is. It's already factored. So use the zero product property and set x plus 2 equal to 0 and 4 minus x equal to 0, and solve, giving us x equals 4 or negative 2. So as coordinate points, negative 2, 0, and positive 4, 0. Okay, don't multiply the binomials out. Okay, that's getting you further away from what you want, which is the values of x. Okay, so if it's already in factored form, then just use the factors to solve for x. So that's our x-intercepts. Let's plot those, negative 2, 0, and positive 4, 0. Now let's get the y-intercept. 0 in for x. So 0 plus 2 times 4 minus 0 gives me 2 times 4, which is 8. So y is 8. So 0, 8 is our y-intercept. So let me plot that right there. Okay, so I have the y-intercept. I don't have the vertex yet, though, so I need to get the vertex. So in order to get the vertex, well, let's look at our equation. It's in factored form, not in standard form, not in vertex form. So I can't just look at it this time and know what the vertex is. I'm going to have to get it into vertex form. Well, in order to get it into vertex form, I have to get it in a standard form first, because we only know how to get it into vertex form from standard form. So, meaning I'm going to need to multiply this out. So when I multiply it out, first outer, inner, last, 4 times x, 4x. Negative x times x, negative x squared. Inner, 2 times 4 is 8. And last, 2 times negative x, negative 2x. So combining like terms and reordering gives me negative x squared, 4x minus 2x is 2x, and plus 8. So now I have it in standard form, and now I'm going to get it into vertex form. So we know to get it into vertex form, we're going to complete the square. So hopefully you recall that we can't complete the square yet because it's not a positive 1x squared. So in order to complete the square, I'm going to factor out a negative 1. The 8 stays on the end. So I'm left with an x squared minus 2x when I factor out a negative 1. So now I'm ready to complete the square. I have a positive 1x squared. So negative 2 divided by 2 gives me negative 1. When I square negative 1, I get positive 1. So positive 1 completes the square, but it's actually positive 1 times the negative 1 out front, which means negative 1 is what I randomly added. So to balance my equation out, I have to add 1 so that the negative 1 that I randomly added goes away. So now I'm left with negative 1 out front, a quantity squared, and that's going to be x minus 1, and then 8 plus 1 is 9. So we can see now from vertex form, the vertex is 1, 9. So we can go ahead and plot that. 1, 9 right there. Oops. Okay, so now that I have that, I can see that this y-intercept is 1 away from the vertex. So I'm going to go 1 away in the other direction to get the mirror image. And now I have several points that I can use to draw my parabola. Whoops, I made that a little bit wide there, but you get the idea. Okay. Hopefully your parabola looks nicer than mine. It's hard to draw on this smartboard. Okay, there we go. So labeling the x-intercepts 4, 0, negative 2, 0, vertex 1, 9, and y-intercept is 0, 8. There we go. Okay, last example is number 3 on the worksheet. So let's start with the x-intercepts. Substituting 0 in for y. Okay, so let's see if this factors. So it doesn't look like it does. Okay, 2 would be the fact, 2 and 1. 2 and 1 don't add to 2. So my possibilities for solving would be quadratic formula or completing the square. We know square roots is out here because it has an x. So now if you think about it though, when we are going to find the vertex, we're going to have to complete the square to get this into vertex form. So if we already have to do completing the square anyway, why don't we solve this by completing the square? So that's what I'm going to do. So I'm going to group the x squared and the 2x. And I have a 1x squared, so I can complete the square. So half of 2 is 1, squared is 1. There's nothing on the outside, so just minus 1. So I have a 0 equals, in parentheses, x plus 1, the quantity squared, and positive 2 and negative 1 is plus 1. Okay, so I'm solving, though, for the x-intercept, so I'm going to continue here. But actually, before we do that, why don't we go ahead and write vertex form so we can come back to that. So we know instead of 0, it would be y, and then this is our vertex form. Okay, so we'll come back to that when we're looking for the vertex in a minute. But we're going to continue to solve because we're looking for the x-intercept. So I'm going to subtract 1. And I'm going to take the square root of each side. On the left or the right, the absolute value of x plus 1. And on the left, we have square root of a negative 1, so we know that's I. So even though I'm realizing that's going to cause a problem on my graph here, I'm going to continue just to get the solutions algebraically. So x plus 1 is plus or minus I. So then x equals negative 1 plus or minus I. Okay, and I do want you to continue, go all the way that you can, even though we're realizing, or hopefully you are, that because I'm getting imaginary numbers, when I'm trying to find the x-intercepts, what that means is I can't plot imaginary numbers on the real coordinate plane. So if I can't plot imaginary numbers on the real coordinate plane, then that means on the real coordinate plane, this graph has no x-intercepts. Okay, so we continued to, even though we realized it up here when we had a square root of a negative, we kept going, and I want you to do that, but I'm going to say none for x-intercepts. It has none. Okay. Now, we might as well list the vertex a while since we pretty much have it. We have vertex form, so we know the vertex is -1, +1. So let's go ahead and plot that, -1, +1 right there. Okay. Now, when you have no x-intercepts and it's a parabola, that means it's either a right side up parabola above the x-axis or an upside down parabola below the x-axis. This one we know is going to be right side up and above because we already have that point that's above the x-axis. So let's see if we can get our y-intercept, and then we'll get our mirror image point, and then we'll have our graph. So y-intercept, putting 0 in for x, 0 squared plus 2 times 0 plus 2. So y is equal to 0 plus 0 plus 2, so that's 2. So 0, 2 is our y-intercept. So I'm going to go ahead and plot that, 0, 2. Now, I can see that that y-intercept is above the x-axis. So, and I don't have any other points because we don't have any x-intercepts. So I'm just going to get that third point by looking at the vertex, which is the -1, 1 right here, and counting how many that y-intercept goes over. It's over just 1. So I'm going to go 1 away from the vertex and plot the mirror image. And now I have 3 points. And once you have 3 points, you can graph the parabola. Okay. So we have the vertex at -1, 1. We have the y-intercept at 0, 2. And there's our graph. So that's it for notes for today. Your homework for this evening is worksheet number 1. You're going to work on problems 9 through 17. And you will have to use the graph paper that I gave you in class or your own graph paper because on the worksheet there's not coordinate planes provided for you. So you'll have to graph those on graph paper. So worksheet 1, problems 9 through 17. Next week on Thursday, you'll have a test that you're going to work together with a team on. That will be graded individually though, so you'll be responsible for your own paper, but that'll come on Thursday next week where you're allowed to talk through problems and discuss, work together with other students. And then the following week on Monday and Tuesday, right before Thanksgiving break, you'll have your 2-day tests. One of the days will be with a calculator and one will be without. The topic we covered today, graphing parabolas, that will be on the no calculator portion of the test. So as you're doing your homework tonight, make sure that you are not relying on a calculator. You're doing it without a calculator.